So we left off from doing probability. Right now we have this sort of an idea. These probabilities that we're going to talk about, they're called, oh, that pencil's broken, binomial distributions. Okay, first of all, what do you think binomial means? What does bi mean? Two. All right, so, and when you talk about a distribution, it's how something is proportioned out. That's how it's distributed. Okay? So we talk about this and we say, suppose an experiment consists of n independent repetitions of an experiment with only two outcomes. That word two right there has to do with the binomial part. Okay? You either have a success, means you did it, or a failure, meaning you didn't do it. P with a parenthesis success, this means the probability that you succeed equals small p. The probability that you fail equals a small q. They just give you those small little things. Okay? Then, what does that big C stand for again? It's a combination. Alright? Then it says all the different combinations of success failures, because you can mix match them, this is how many, all the different combinations. Okay? This is a P, and I don't know if you can see that, but that's a little r there, to the r power times q, and then it says to the n minus r power. Let's do this example right here, and then that'll give us a better idea. Okay? All right. Taylor, will you read it for us?
Suppose Tom makes 92% of his free throws. If he shoots 15 free throws and his chance of making each one is independent of the other shots, what is the probability that he makes all 15?
Okay, so right now, okay, what is the small p? What is the probability of success that he makes a free throw? 0.92, because that's it right there. Okay, that's a success. Now, Q is the probability that he misses or the probability of failure. Yep, 0.08. Okay, so we have that information. And N, in this case, equals how many? 15. And if his chance of making one is independent of the other. Okay, what that means is every time he goes up to the line to shoot a free throw, every time he has a 92% chance of making that free throw. We all understand that realistically in a real game, there might be screaming fans, there could be sweat dripping in his eye that causes him to miss, but in an ideal situation, every time he steps to the line, he has a 92% chance of making that free throw. That's what that means. Yes, Evan.
Wouldn't you multiply 0.92 by times 15?
Not times 15.
Well, like times it, like 0.92 times 0.92 15 times.
Okay, to 15 times. Yes. So what you're saying is we want to know the probability that he makes all 15. So that's going to be 0.92 times 0.92 times 0.92. That's right, 15 times. But let's go back up here and look at this formula for just a moment. Okay? R is how many times he's going to shoot, and he's shooting 15. So this would be like saying 15, C, 15, and then we'd say P to the R, which means times P, which is 0.92, to the 15, times Q, which is 0.08, but it's raised to the N minus R. N is 15, R is 15. So it would be 15 minus 15. This equals 15C15. Do we know where to go on our calculator for that? You go, I think we talked about it was like second window or something. You could. A shortcut way is alpha window. and it's down there in number 8. So we would do 15, 15, and we'd get 1 times 0.92 to the 15.
Why would you times it by 0.8?
I am following this rule right here, okay? And in this case, we do want to know the probability that he makes all 15. But let's say they were asking what's the probability that he only makes 6, okay? And we'll do that in this one. So, but yes, up here, Evan, your intuition is totally correct. I'm just following the formula to show you, because 15 minus 15 is 0, that if you use the formula, you get the same thing as what you intuitively knew to do. Does that make sense?
Yeah.
Okay, so 0.92 to the 15th. All right, so he has a 0.286 or a 28.6% chance of making, that's the probability he will make all 15, okay? Okay, now, the next situation's a little different. Suppose the same thing, he has 92%, so that's my P. Shoots 15 free throws. If his chance of making each one is independent, what's the probability he makes exactly 10? R equals 10 now. Okay? And so, now, maybe some of you are thinking that it's just 0.92 times 10 and 0.08 times 5, or to the 5th. But the problem is, there's a lot of different ways he could do that. He might miss the first 5 and make the last 10. He might make the first 10 and miss the last 5. He might make the first 2, then miss 5. Do you see there's all these different combinations of how he could do that? Which is why we need this part right here. That is why we need to say 15C10 in the beginning.
But why would the order matter? Yeah. We're just looking at combinations, not permutations.
Because there's lots of different ways that he could make the 15.
But he's still just missing 5. He's still going to make exactly 10.
He is, but we don't know if it's the first 10, the middle 10, a scattering of 10, but we just know it's 10.
But it's not asking for like what order, it's just asking probability.
That's right. It doesn't say, now if it said what's the probability that he makes the first 10, then we can go with this. But it doesn't say when he makes the 10. Any of the 15 times he can make 10. It doesn't matter what order, he still has exactly 10. So you have to keep track of all those different ways that you can make exactly 10. And that's with the combination. Because order doesn't matter, like you said. That's why we need to do the combination. So then we go to our calculator, and my best thing is just to type everything just in here. Alpha window, go on down, and it's 15, 10, that doesn't seem right.
Maybe it'll be like a P on a C.
No, you still use the C.
Why? Because C weighs the order doesn't matter.
Right, and the order that he makes them, it does not matter.
And why does it matter? Like,
It matters that there's a lot of different ways that you could do it.
why? But it's just asking him if he
I know, but there's so many different ways to make 10.
Yeah, but it's not asking for that.
But it's asking for the probability that he makes exactly 10. It doesn't say we have to do with he could make 10 this way. Make.
Yeah, but he's just making 10 though.
Right.
You know the probability of it. They're asking for the probability. So
Okay.
you can't just like not have those because you think that is not.
There's still the chance that you could make 10 by missing a couple.
But he's just still making 10 though.
He is. But you have to keep track of all those different ways. You've got to take that into account.
Why would that contribute to his probability? He's still gonna make 10.
But it's adding more ways.
It's adding more ways.
It's a different fraction that way. It's, instead of 1 out of 10 attempts, it's like 1 out of 100 if you count all the times. That's just a different example.
Yeah.
Yes, if that helps. I don't know if it does or not. Obviously it may not, but okay. So this is what we have. This is how we do those when we have this information. And now we're going to do something called conditional probability. Okay. Conditional probability is the event B depends on some other event. And this is how it's written. This is called the probability of B. The probability of B given A. Okay? So given A already has occurred, what is the probability of B? And it equals the probability of A and B divided by the probability of A. That one right there. Okay? So, let's go back to this chocolate chip one. Do you remember the cookies in the chocolate chip?
Yeah.
Okay. Suppose we have drawn a cookie jar at random from one of the jars in example 6. Given that it's chocolate chip, what's the probability that it came from jar A? So the way that we would write it is the probability that it came from A given it was a chocolate chip cookie. All right, does that make sense? All right, so what we do is, oh wait, maybe I misdid this. Hang on. No, it says given that it's a chocolate chip, what's the probability that it came from A? Okay, so your little diagram that we drew on the other page for example 6, remember this one right here? Okay, and we went out and we did all of that. Okay, so what we have to do in this case is we have to do, this is the probability that it is A and chocolate chip divided by, yes,
Wouldn't A be the chocolate chip?
wouldn't A be the chocolate chip?
So the given is A, right? So it's given that it's a chocolate chip, so shouldn't A be the chocolate chip?
Well, but this is just jar A.
So are we talking about the jar or us?
You're confused?
Yeah. Because it says we're given the chocolate chip, so it's probability of B given A. So A is given.
Oh, I see what you're saying. No, whatever's after the word given, you just write that second. That goes after the line. This is still fine. This is like saying jar A. The probability that, what is the probability that you chose from jar A given the cookie you grabbed was a chocolate chip cookie? Okay? All right. And then you divide it by the probability that it's a chocolate chip cookie. Okay? Now, what is the probability that it is from jar A and it's a chocolate chip. Well, let's go back to our tree diagram. What was the probability that it was from jar A and it was a chocolate chip? Look at the end. It was 1/4. It'd be 1/2 times 1/2. Okay? So what we could do is just say 1/2 times 1/2. And then what is the probability that you draw a chocolate chip cookie? Well, on the front here, the probability that you draw a chocolate chip cookie is 1/4 plus 1/2. So that is 3/4. So that's,
This is your thing.
yes.
When we're dividing, wouldn't we be dividing by the problem, by P of A instead of P of chocolate chip?
Well, that's confusing because of how it's written. But if you look, what I want you to notice, the A's are making it confusing, but what I want you to notice is you always divide by the second, whatever is second. Okay? So if chocolate chip is second, that's what you divide by. All right? So then we get this, and the answer is 1/3. You have a 1 in 3 chance.
How do you get 4 with 3?
Okay, this is 1/4 divided by 3/4, which is the same as 1/4 times the reciprocal of that. And the reciprocal of 3/4 is 4/3. Okay? All right. Okay, guys, here we go. Let's try this one. Roll a fair die 4 times. Okay? So here we go. Let's roll a fair die 4 times. What is the probability that you roll all 3s? Okay? What's the probability you roll a 3 the first time?
1/3. 1/12.
And I'm... Okay? Make sense?
Well, really that big?
What?
That much of a chance?
1 in 216.
Wow, it seems like it should be way less than that.
Yeah, no. You have a 1 in 216 chance of rolling a 3 times in a row.
Yeah, it seems like it should be way less than that.
Yep. Which, I guess if we wanted a decimal, then it would be really small. Okay? Oh, wait, it says rolling it 4 times. Sorry, guys. We have to go to the 4th power now. I know. So, wow, it's 1,296. And that is 0.12377. It's a very small chance. Okay? What's the probability of rolling no 3s 4 times? What's the probability of not rolling a 3 right here?
Pretty good.
5, 6? Yeah. So 5, 6, 5, 6, 5, 6, which is just basically 5, 6 to the 4th. And again, just go ahead and do that on your calculator if you want. And you get 625 over 1296, and .48. So that's a better chance.
Less than 50 though?
Yes, you have a less than 50% chance of rolling no 3s.
It doesn't seem right.
I know it doesn't seem right, and you're thinking, come on, maybe the odds. Okay, what about rolling exactly 2 3s? Now, once again, sorry, but Alec, I could do this. I could do this.
So you're saying the number of times that you could possibly roll through, not just
Correct.
Not just rolling 2 3s, a number of ways possible.
All the ways have to be included. Okay, so all these,
Would that be permutation then?
no, order doesn't matter with combinations. So it's,
You've been saying that order does matter.
No, it's the combination of like where the 3 is rather than the order. It doesn't matter which combination comes first, it's just.
yeah, it doesn't matter the order here. It doesn't matter when I get the 3s, I just have to have 2 of them.
Fair enough.
Okay? These two, twice I get a 3, twice I don't get a 3. There are 4, combination 2 ways of getting it. And if I do all that out on my calculator,
You would count it as 3
yeah, that's what it is. So really it's what, about a 12% chance? Very small chance, okay? So when I'm playing Yahtzee, I'm going to remember all this. Okay? All right, this is conditional probability. All right, last side. Now, sometimes when we're doing probability, we are going to use Venn diagrams to organize these, to help with them, okay? Does everybody remember what a Venn diagram is? Yep, they're little overlapping things, okay? A and B is the middle part, okay? A or B is all 3 small sections added together, okay? So, let's see if we can draw a Venn diagram with this information. The probability of A is 0.6, B is 0.3, and A and B is 0.2. My advice, put the A and B in the middle first.
So then you subtract it from.
Right. So now A, you guys, A is only this circle, and it has to equal 0.6. So how much do I need right here? I need 0.4 there. And then B is this circle, and it has to be 0.3. So I need just 0.1 there. And they want to know then what is probability of A or B. So the probability of A or B equals 0.4 plus 0.2 plus 0.1. That's what they told us to do. Add each of the 3 small sections together. And that would be 0.7. Okay, now let's see if we can do this next one. Now in this one, okay, this is A.
Wait,
Yep.
isn't or multiplying?
No, or, excuse me, add. And is multiply. Okay, so the probability of A is 0.4, so these 2 sections have to equal 0.4. B, these 2 sections have to equal 0.3. And then 0.5 is when I add all of these 3 up, I need 0.5. So I need to know, guys, what do I put in the middle? See if you can play around with that. What would you put in the middle? Did you just guess and check? Okay, let's just say that the middle is 0.1. Let's just say it is, okay? Then that means this is 0.3, right? And this is 0.2? What is 3 plus 0.3 plus 0.1 plus 0.2? Okay, probability of A is 0.4. That means this circle, these 2 have to add up to 0.4.
Okay.
And I just made up this just to try it. When it's B is 0.3, these 2 have to add to 0.3. Now, or means that when I add all these 3 together, that it equals 0.5. This does not equal 0.5, so it must not be 0.1 in the middle. So I gotta try something else. What should I try in the middle? Try 0.2. Then how much is this one?
2,
And how much is this one?
1.
1. There you go. The probability of A and B equals 0.2.
Before, oh wait, yeah,
I thought Amy was me.
Okay. And is multiplying. So what that means is, but that's only if the events are independent and they don't affect one another. They do affect one another here because they overlap. Okay? All right, let's look at this last example. In a large high school, 54% of the students are girls, 64% of the students play sports. Half of the girls at the school play sports. What percentage of the students who play sports are boys? Okay. We have to come up with some sort of a Venn diagram. What categories do we want in the Venn diagram? Boys and girls or sports and something?
We want both?
Well, you can't have 3. You can only have 2 things. So you can only have an A and a B.
boys and sports.
Well, but they don't give us any information about boys. That's what we have to find out. How about we do the girls in sports? Okay, so this is girls. This is sports. Okay, now obviously, if you're not girls and you're playing sports, this must be the boys, right? What is this area outside here? Boys who don't play sports. Very good. There's no boys and they don't play sports. That's right. Okay. All right, in a large, 54% of the students are girls. So that means in these 2 sections, that's 54%. 62% of the students play sports. So in here is 62. Okay? Half of the girls at the school play sports. Okay? So half of the girls play sports. Where should that go? In the middle. 0.5. So, what percentage goes out here?
0.49.
Because then these 2 add up to 54%. So what goes over here? Oh, wait, I wrote that wrong. This says half of the girls at the school play sports. Okay, that's not, sorry. Because we need to know, this one's kind of tough. All right. We'll figure it out. Okay, so half of the girls, all right, I'll tell you what, we will work on this one. Okay, your homework is this part down here. I'm going to stop right here because we're recording it, and so that way they don't need to watch us bumbling through it. So there's your homework on the rest of that.